Let's take question number 28. Integral dx upon x cube into 1 plus x6 whole to the power 2 by 3 equals given something. So we have to talk about what is fx. Let's integrate this one. Say I equals integral dx by, when we look at this term, we can simply see if we try to take x6 out of it, then it will become comfortably integrable. When you take x6 out of it, it will come out as x6 to the power 2 by 3, meaning x to the power 4. So let's write it. x7 into 1 plus 1 by x6 whole to the power 2 by 3. Benefit we can clearly see if we put 1 plus 1 by x6 as t raised to the power 3, we are getting minus 6 upon x7 dx is equal to 3t square dt. Therefore, integral is now, we can see here dx by x7 is simply minus of t square by 2 dt. So let's write here minus 1 by 2 t square dt divided by t square. That's clear. So we are getting minus t by 2 plus constant of integration. Let's write the value for t. So here we have minus half multiplied with 1 plus 1 by x6 whole to the power 1 by 3 plus constant of integration, or minus 1 upon 2. We can see here x6, if we take LCM, it will come out as x square multiplied with 1 plus x6 whole to the power 1 by 3 plus c. Again check what is given to us. 1 plus x6 whole to the power 1 by 3 is there, multiplied with x into fx. So let's write here minus x upon 2x cube 1 plus x6 whole to the power 1 by 3 plus c. So clearly fx is minus 1 upon 2x cube. So let's see from the given options, minus 1 upon 2x cube, that is option number 1 is the correct answer. Moving on to the next one, that is 29th question. If the eccentricity of the standard hyperbola passing through 4, 6 is 2, then the equation of the tangent to the hyperbola at 4, 6 is. So let's start this one. Let's say the equation of hyperbola be x square by a square minus y square by b square equals 1. Now eccentricity is 2, meaning b square equals a square into e square minus 1. So from here we have the result b square is equal to 3a square, say equation number 1. Now we have to find tangent at 4, 6, meaning 4, 6 is lying on the hyperbola. Since 4, 6 lies on hyperbola, therefore 16 by a square minus 36 by b square is equal to 1. Now if I put b square as 3a square, what I am getting? 16 by a square minus, substituting 3a square, it becomes 12 by a square is equal to 1. This is from 1. Correct? So we simply get result changing to 4 by a square is 1, or a square is equal to 4, b square is equal to 12, hyperbola is x square by 4 minus y square by 12 is equal to 1. What next? We need equation of tangent at 4, 6. Therefore, tangent at 4, 6 is 4x by 4 minus 6y by 12 is equal to 1, or simplifying we can write 2x minus y is equal to 2. Let's check from the given options. 2x minus y is equal to 2, that is option number 4 is the correct answer. Let's move on to the next one. So let's take the last question of this paper. Let f from R to R be a differentiable function satisfying this equation. Then we have to talk about the limiting value of it. So let's check this one. If we substitute x approaching to 0, we observe 1 plus f3 minus f3 upon 1 plus f2 minus f2. So it is 1 to the power infinity form. So we can write this one as limiting value equals 1 plus this entire thing, 1 plus f of 3 plus x minus f3 divided by 1 plus f of 2 minus x minus f2 minus 1, now whole raised to the power 1 by x, so that we can write it as e raised to the power term. So simplifying it further, under the limit x approaching to 0. So this gives us limit x approaching to 0 e raised to the power. Taking LCM, we can see 1 is cancelled. We are left with f of 3 plus x minus f3 minus f of 2 minus x plus f2. This term is in numerator, right? Divided by 1 plus f of 2 minus x minus f2, and the whole thing is multiplied with 1 by x. So right here 1 by x. This is clear. We know on applying limit it is 0 by 0 form, because we already know f3 minus f3 minus f2 plus f2, it is 0. Denominator we can see it is already 0. So we have 0 by 0 form over here. Applying L'Hopital to this term, we have limit x approaching to 0 e raised to the power f dash 3 plus x plus f dash 2 minus x divided by x multiplied with minus of f dash 2 minus x plus, we can take the derivative of x now, 1 multiplied with 1 plus f of 2 minus x minus f2. So I'm sure this entire thing is clear what we are doing over here. Just apply the limit now and check what we are going to get. On checking the limit, we observe here it is f dash 3 plus f dash 2. Now this is given to me some value in the question itself, that is 0. Right? Now let's move on to the denominator part. Denominator, we see when you put x equals 0, it becomes 0. Now here we have 1 plus f2 minus f2, that is 1. Numerator is 0, denominator is 1. So clearly the value is 0. So it is e to the power 0 or simply 1. So let's mark the correct answer for this question, option number 2. So this was the last question of this paper, evening shift of 8th April 2019. I'm sure this is clear. Thank you for watching the video.